Assalamualaikum and hi to all students. Okay, so we meet again to continue on our lecture, which is lecture 7. Okay, so for this lecture, it is about estimation. Okay, so previously we have been exposed about the introduction involving samples, populations, okay, and the measurements of the central limit tendency. Okay, so now after all those exposure on measurement, so now we want to know at the next stage of how to estimate, okay, on our statistics, okay, on the data, the sample, okay. Okay, so basically the topic or the learning objectives in this topic. Okay, the first one is to understand the basic concept of estimation, how you want to estimate. Okay, and then the types of, which is the difference between what is point estimation and what is interval estimation. Okay, and then we want to know to form and interpret confidence intervals. Okay, confidence intervals, which is we involve distribution. Okay, and of course it involve the population mean or proportion, the one that we have learned in the past or previous lecture. Okay, so we have two types. We have Z distribution, we have T distribution here. Okay, and the last one is to determine the appropriate sample size. Okay, what is the N? To achieve a specified levels of accuracy and confidence. Okay, so we will cover all of these subtopics in this estimation. Okay. Okay, we go to the slide number 4 here on estimator. Okay, so the point estimator, we have only single number. Okay, only one single number, some particular value given. Okay, so it is a statistic that is calculated from sample information and we use it to estimate population parameters. Okay, so this is the example, okay, on point estimator. Okay, other than that, okay, for this point estimator, okay, so another example is the sample mean x bar is a point estimate of the population mean or the mu. Okay, so we write as notation for sample mean, we write it as x bar, right? This is for sample mean. And we write it as mu for population mean. Okay, so this is a sample of point estimator, a single number only given for point estimator, compared to another one, a type of statistic, which is interval. Okay, it's a range. So interval estimate is defined by two numbers between which a population parameter is said to lie on. For example, okay, in between your x bar for expect sample mean, right? Okay, and less than b. So it is an interval estimate of the population mean with mu. Okay, mean with mu, mean population mean. Yeah, I write it here so you have better population mean. We write it as mu. So it indicates, okay, that the population mean is greater than A but less than B. So this is example of interval estimator. Okay, so what does this mean? Point estimator and interval estimator. So if the mean population is within the range of the upper limit, so this is the upper limit. Okay, let me find another color here. Okay, this is upper limit. Okay, and it must be within the range of this upper limit and also your lower confidence limit. Okay, so that the statement regarding your mu is considered as true. So this is the width between lower and upper of your confidence interval. So the middle one is the point estimate. Okay, point estimate is single number only, but for interval we have two. Okay, So another one is the confidence intervals. Okay, this confidence interval is actually being used by statisticians to express the precision and also uncertainty, okay, which is associated with a particular sampling method. So basically, a confidence interval, it consists three parts, okay, which is first the confidence level, okay, confidence level. So involve three parts, okay. We have confidence level, then we have statistic. What is the statistic? And the third one, we have margin of error. Okay. Okay, so this is the attribute of estimator. So expected estimator should be unbiased and have a consistency and relative efficiency. Okay, so basically this is just features of expected estimate. So before we proceed with the samples of questions, so this is confidence level. So I expect that you have read all these notes, okay, before our lecture, because I've already uploaded earlier. Okay, so basically confidence level is the confident that the estimated interval will contain an unknown population matter, so that it will contain or cover that's between upper and lower limit. It will be in that range. Okay, so percentage of confidence of less than 100% can be 95% sure, 99% sure. Okay, so that is the confidence level, but cannot be 100% confidence, because as we know that this is what we call probability. It cannot be 100% true, right? Okay, and confidence level is, so how we know it, it is 1 minus alpha, so that you get your confidence level. So alpha, we call it as level of significance. For example, if alpha is the level of significance 0.05, though, so it will be 1 minus alpha, which is 1 minus 0.05, you'll be getting 0.95. Also in percentage, it is 95% confident on that estimated interval will contain an unknown population parameter. So that's how we elaborate or interpret the meaning of this 95%. Okay. Okay, so basically, for confidence level, so we have population mean. This is one that we have learned in previous lecture. This is population proportion. Okay, so in this population mean, okay, we have, what is this symbol means? This is standard deviation. Standard deviation, okay, or standard error. If it is unknown and if the situation we know the value of your standard deviation. So basically, confidence interval for mu or population mean, if your standard deviation is known, okay, so how you want to estimate the confidence interval? So be using x bar, which is your point estimate, plus minus with your z alpha 2. What does it mean here? Okay, this is your confidence level, right? So it is actually the critical value. Why is it alpha divided by 2? As we look at the previous one, it will be in between, right? So, and also it is always in bell shape. So of course you will have to divide it by 2. You have right tail, we have left tail. So the critical value of the normal distribution, and also this is normal, right? So bell shape is basically a normally distributed, of the probability of alpha divided by 2 at each tail. This is what I mean, tail, left tail, right tail. And this is what we call as standard deviation. Okay. Okay, so applications of confidence level. So when you're given this alpha and you get your confidence level 90%, 90%, right? So this is your confidence level, and how you calculate this confidence coefficient. So what is the value of Z alpha divided by 2? So for example, 90%, they get this 1.645. How do you think they get this value of 1.645? Okay, so we move to this table. This table I given to you in the notes. Okay, also, okay, it's in the last page, okay, of the slide. Okay, so for this Z, 90%, right? So the value of Z, okay, Z alpha divided by 2. So you know that it's given to you that the confidence level is 90%, which means that your alpha is basically, so your alpha is basically how? So you get it by 1 minus with alpha. Okay, so when you get this 1 minus alpha, you get 0.90 here. Okay, so alpha is basically 0.10. So when Z 0.10 divided by 2, it is actually Z 0.05 here. Okay, so how we find that it is actually 1.645? So basically, because this table is giving approximate to 2 decimal places, so we can round up to 1.65. Okay, it depends on the table that is given to you. Okay, it's either way. This is also correct because this is only 2 decimal places. There are also table which have 3 decimal places. What I mean is that in this example, they give you 1.645, but this is 3 decimal places. Okay, 1, 2, 3. Okay, but this table give you 2 decimal places. Okay, maybe you can round up this into 1.65. Okay, so we find 1.65 here. Okay, but because we don't know this value, we only given to you 0.05, right? So you have to search in this value, I mean in the table here, which give you or of your confidence level here 0.05, or you can say that it is if here is 0.05, so it should be 1 minus 0.05, you'll be getting 0.95. So approximately you need to search for this one. So from the table, what I can find is that it is here approximately near to this 0.95 here, okay, which is give me 1.65. so this is what I said to you. Okay, and this is how we find the value of your Z alpha divided by 2. Okay, so now we move to the next, we move to the first example. Okay, so this is for population mean, which we know the standard deviation if this is the situation. So a sample of 11 electric circuit from a large scattered population has a mean of resistance of 2.20 ohm. From previous tests, it is known that the standard deviation of the population is 0.35. Okay, so this is the standard deviation of the population, and determine 95% confidence interval for the actual mean resistance of the population. Okay, so how do we solve this kind of question? Okay. Okay, it's given to us that we assume confidence level is 95%. Okay, so 95%, which means that your 1 minus alpha is actually 0.95. So your alpha is actually 0.05 here. Okay, so your Z alpha divided by 2 is actually plus minus. So this one you need to refer to the table. How you find this 1.96 here? Okay, so we need to refer to Z table. Okay, now when we look into this table, remember how I find that it must be divided by another 2, because when we look at this bell shape, right, we have this left tail, right tail. So we have two-sided that we need to cover for this Z alpha divided by 2. So just now you have calculated that it is actually alpha equals to 0.05. So basically it is alpha, it must be divided by 2 for this right tail and left tail. So you actually be getting 0.025. So basically you need to search for the value of 0.975 from the table. Okay, 1 minus with this 0.025, so you'll be getting because 1 minus with your alpha, right? So you need to get this value, so you'll be getting 0.975. so you need to find approximately this value in this table. So you look at the nearest to 0.975, which is here. Okay, that gives you the value of 1.96 equals to 1.96. so this is how they get that value, plus minus. Why plus minus? Because we have this right tail, which is the positive one, and the negative one for the left tail. That's why we have plus and minus 1.96. Okay, so we already know how to find this value of z, right? Okay, so I hope you can try to apply this in other questions. So as we have find under just now, so your z left tail will be negative 1.96. Okay, 1.96. Okay, so the value here will be 1.96. Okay, 1.96 negative. So on your right tail will be this is positive 1.96 here for your upper confidence level. So basically, this is how we count just now. Alpha divided by 2. You know that is actually 0.05. So 0.05 divided by 2. So you are actually getting this half on your right tail. And also the other half is actually your left tail, 0.025. Okay. 0. So here, sorry. Okay. So actually this 0.025 here. Okay. So using Z cumulative table, so this is what you'll be getting on your lower confidence limit and also your upper confidence limit here. So for that example, after you have already get the value of your Z, right? So we want to find, okay, we want to solve it. So once you get your 1.96 value, okay, so we use this formula. So this is the solution. Just now we only get your value of your Z alpha divided by 2. So we haven't yet solved the question. So solution is actually x bar. Remember the formula in the previous slide, x bar plus minus with your Z alpha divided by 2. So basically just now you only find Z alpha divided by 2, the first step. Okay, so now only we want to use this formula and plug in all the information from your question. So basically the question give you your x bar equals to 2.20, okay, plus minus with you already get your Z alpha divided by 2, right, which is 1.96 plus minus. And also this 0.35 is actually given in the question because it is known, right? Your standard deviation is known. So 0.35, so divided by the sample size, which is 11 here. Okay, so basically you'll be getting 2.20 plus minus. So I hope that you calculated this, and you should be getting 0.2068. Okay, so basically it will be, the confidence interval will be between 1 point, because you have plus minus, right, 1.9932, okay, and it will be between 2.4068 here. So this is why this is why and how we solve this question. So the first step, you find your value of Z alpha first. Okay, and we know that it is two tail. It is two tail, right? So left, right and left side. Okay, and that's why, because it is in the middle, so we want to find that the mean population is lie within this range of upper and lower limit. So this is the range. Okay, and you know that you already get the value that left hand side and also right hand side, so it should fall. So it is, what does it mean? It is believed that 95% of the actual mean resistance is between 1.9932 and 2.4068 ohm. So this is how you interpret this question. Okay, so basically that is for if your standard deviation is known. But if in the case that it is unknown, so we use t distribution instead of normal distribution, because it is the situation add to uncertainty, because S is different from one sample to another sample. Okay, So basically, this is how we want to estimate confidence intervals if your standard deviation is unknown. Okay, so if not given to you, so we need to use student t distribution and we need to use this formula. So basically, if you look at this formula, it is quite similar. It's just that because we use t distribution, of course, we replace z with t. Okay, and your standard deviation, we do not use the sigma notation, but we write it as S here. Okay, S. Okay, uppercase S. So it's, all this alpha divided by 2 still means the same like we run for Z also. Okay, but we need to plus with net n minus 1 degree of freedom for this t distribution. Okay. So let's go to the example on how we want to try to solve for this unknown of a standard deviation. Okay, so the value of t alpha divided by 2 depends on the degree of freedom, df. Okay, so df is actually equals to n minus 1. Okay. And this is how we read from student t table. So let's say your n equals to 3. Okay, so your degree of freedom must have your number of sample size and minus with 1. So you'll be getting, actually your df is 2. So if you are given your alpha is 0.1, so basically alpha divided by 2, you should be getting 0.05. So you need to look from the table 0.05, and also for your df is actually 2. So this is degree of freedom of 2. So we can look at the t table. Okay, so we can look at this table that I attached in your slide. Okay, so this is your degree of freedom 2, right? So we find that if it is a two-tail, it will be 0.1 just now, right? So when you divide it by 2, for each of the tail, which is your one tail, is actually 0.05. That's why we need to search at here. So basically, just now, for the each tail, which is that you divided your t, okay, sorry, problem here. So basically, your one tail here will be your 0.05. You already divided your alpha, which is 0.10 here. So your two tail is actually 0.10. So your df2, and you read it here, 2.920. So remember that your alpha is actually for your two tail, right? 0.10 or 0.10. So not confusing yourself. Okay, so and then when you divide it, so you get for each tail 0.05. That's why you read it here this way. So 2, and you get 2.920. Okay, so we have looked how we want to read from student t table already, right? So I hope that all of you can try to practice to find for how to find the value from t table. So it's quite a bit different lah from compared to Z table, right? Because you need to have this df, okay, degree of freedom, and also you need to have the upper tail and lower tail, which involve one tail and two tails. So focus yourself. So two tail, which means that you look at the value here, okay, two tail, and one tail value you look here. Okay, then only you refer to the table. So one tail value is this one. This is the two tail value, and you need to find the degree of freedom 2. So all of it is here. Okay, so remember that this is the two tail, this is one tail. Okay, so now we can move to the example. Okay, if let's say they give you, assume a random sample n equals to 25, your x bar is 50, your s, okay, it's not standard deviation, your s equals to 8. It is for your standard deviation for your sample here. Okay, so construct 95% confidence interval for mu. Mu is actually for what? For your population. Okay, so the first thing, what is your degree of freedom? So the formula is n minus 1, right? So basically 25 minus 1, you'll be getting 24. Okay, so the next one, you know that the alpha is actually what? alpha is actually, you have this 95%. Okay, so basically 1 minus alpha, you get this 0.95 here. Okay, so your alpha is actually 0.05. So your t alpha divided by 2 is basically going to be 0.05 here divided by 2. So you'll be getting 0.025. So how? You need to find this value first from the table. The same step like we did for Z table. Once you get the value of Z alpha divided by 2, you go and find from the Z table the value of this. Then only you can proceed to the next step. Same goes to T table. Okay. First, you construct. You write first the information. What is the DF? Okay. What is the alpha? So once you know, so this is alpha for your 2 tail and this is the alpha for your 1 tail. Okay, so you need to find the value of this one first. What is T alpha divided by 2? Okay, so again, we refer to the table of T distribution here. Okay, so you know that your degree of freedom is what? 24. Okay, so we look at 24 here. And you know that your alpha of 2 tail is actually 0.05. And your, your 2 tail is 0.05. Okay, so your 1 tail is going to be 0.025. Okay, so basically it's going to be around here. So 24, so you'll be getting 2.064. So 24 and here. 24, sorry, here. 2.064 here. So if you look at this table, this is 3 decimal places. So in this slide, in your notes, if you look at the information of the T value, it is given to you 2.0639, right? So don't get confused. It's just okay because it's just a matter of decimal places only. If you Google, you can find that there are also another T table that give you 4 decimal places. Okay, but for this slide, I mean for your notes, I attached the table that is 3 decimal places. So it is not, it is just, it is still correct. And it doesn't affect anything. Okay, it's just a decimal places. So what I want to emphasize here is that student need to know what is the DF, okay, and also 1 tail and 2 tail. That's why it is very important you to jot down. Okay, once you get the your question, you need to write the information. Okay, so like just now I told you DF is 24. Okay, fine. Now alpha is basically this one that you're getting is actually for 2 tail. So you need to read from 2 tail then 0.05. And then when you put T alpha divided by 2 here, so you know that you're getting another one. So this is the value for your what here? So this is the value for your 1 tail. 1 tail on your right and on your left. So each of it will have this one. So that's how you read from the table. So basically this is what you get, 2.0639, or basically from the table just now it is actually 2.064 here. Okay, 64. Alright, so then only you can construct your confidence interval. Okay. Okay, so basically confidence interval. So what is the formula that we use for this T distribution? Okay, X bar plus minus with T alpha divided by 2. So you are not using standard deviation because it's not given to you. So you use S divided by square root of your N. So basically your X bar is 50. So plus minus, you already get this value here. So from this step, so you just plug in only. Either way, you can put 2.064 or 2.0639. Either way, it's still okay. Okay. And then this S is also given here, right? So add 8 divided by square root of 25. So you just calculate it and basically you should be getting the range, which is approximately, because plus minus, so you'll be getting 46.698 in between mu here, and this is the upper side, which is 53.302. So this is the aim, how you want to find the confidence interval. So when the question said confidence intervals, what is your mind? It is interval between a range of lower and upper limit. Okay, so that's the basic of finding Okay, now we move to the confidence interval also, but proportion population. So this is the notation pi. Okay. So estimated intervals for population proportions of pi can be calculated by taking into account this uncertainty of the proportion of the sample, which is p. Okay. Okay, so when we recall, the sample proportion distribution is approaching normal if the sample size is large. So this is standard deviation for proportion and estimates with sample data. Okay, so sample data, which means that proportion for sample here. So this is for population. Okay, so we use pi. Okay, so how we want to find the proportion confidence interval? Okay, so same like just now, when we have this confidence interval for mean, but we have unknown standard deviation and known standard deviation. So now the first one is for proportion confidence interval. So slightly different, but almost the same. It's just that here we use as P for proportion, but just now we use as X bar, which is the sample mean. But P here denotes for sample proportion. Okay, and the same here is Z alpha divided by 2, so standardized normal value of the desired level of confidence. So this is still the first step that you need to search and calculate for before you proceed to find the confidence interval. So here is basically the standard deviation, same like just now. For your mean of your sample and population, we use standard deviation, but because this is proportion, so this is the formula that we plug in here. So basically this is P, right? So for sample proportion, so sample proportion and divided by the sample size here. Okay, so we move to the next slide. We give you example. All right, so a random sample of 100 people shows that 25 people are left-handed. So form 95% confidence interval for 2 true proportion of left-handers. Okay, so the first thing is that if you look into the slide, they skip already on how they find the value of Z alpha divided by 2. But you know that this is 95%, right? So 95%, so if you look from Z table, you should be getting this 1.96. So refer to the previous explanation on how I get this. Okay, I just keep this because I have already explained just now, right? So basically, the formula is here, proportion plus minus with Z alpha divided by 2. So basically, times with your proportion 1 minus with your proportion of your sample divided by n. Okay, so you plug in the information. Okay, what information that you have here? Basically you have your proportion. So basically proportion is in percentage. So a random sample of 100 people from a random sample, the total is 100. So it takes only 25%, or the desired proportion is left-handed 25. So basically we find 25 of left-handed, right, over 100. Okay, plus minus with the Z value of 1.96, and then we just plug in the proportion of 0.25 here, 1 minus 0.25. Okay, and divided by n. How many is n? 100. Okay, so this is how we plug in and we calculate for this formula. So I hope that you try to calculate for this one, and basically you'll be getting the confidence interval of this proportion is between 0.1651 between of this pi, okay, because it's a population, and 0.3349. So this is basically how you use. It's quite similar, it's just different from this proportion side only, but the other one Z is still remain the same like the previous calculation. Okay, so the last section for this topic is the determination of sample size. Okay, how we want to determine sample size? Okay, for first we have for mean and also for proportion. How to determine the size of the sample needed to estimate population proportions. Okay, so basically determining the sample size for mean. So we refer to the formula of your mean here. So we just actually modify the formula to get this equation here. Okay, but this is actually to find for sampling error, which is the margin of error first. Okay, and then from here, okay, we move or we solve n. and get into this equation. So n means you get the sample size. So actually modification from the formula, and then we start with sampling error, we move to this equation. So this is basically how we apply the formula to find the sample size. Okay, so example, sample size needed. So if standard deviation is 45, what is the sample size required to estimate the mean with sampling error plus minus 5 and 90% confidence? So you already know the formula. N equals to Z squared, standard deviation squared, over E squared here, equals to, so what is your Z basically? It's given to you that it is 90% confidence, so you need to find for the value of this. Okay, then only you plug in into the first formula. So basically for 90%, you should be getting 1.645. You can refer to the steps that I've explained in the previous slide. How you get this value of 1.645 is from this Z, okay, Z of 90% here. Alright, so your standard deviation they give to you is 45 here squared divided by your E squared. What is your E squared? Okay, it already give you with a sampling error between plus minus 5. So basically this is 5 squared. So once you calculated this, you should be getting this 219.19 here. So the sample needed is, so you approximate to the nearest decimal places. So 220. So always round up to the greater value of 219.19. So we round up to greater value, which is 220. So basically, this one applies the same steps on how to find for Z value of 90% confidence. Okay, so be careful on the value that you plug in here. So the others remain the same, you just plug in, okay, but except for Z, you have to be careful. So the next is the dimensions of sample size. Just now is for mean, now is for proportion. So same, they modified the formula from that proportion into sampling error and then solve to obtain your N or your sample size. So the example, determination of sample size for proportion. What sample size is needed to estimate the actual proportion of damage in large populations with sampling error plus minus 3%, 95% confidence? So we assume pilot sample produce P, which is a proportion of 0.12 here. Okay. Okay, so at 95% confidence, your Z alpha divided by 2, you should be getting 1.96. So E is given to you 0.03 and P is also given to you from the information 0.12. So we use the information to estimate your pi. Alright. So the formula sample size for proportion is actually Z divided alpha divided by 2 here squared, then pi 1 minus pi here divided by E squared. So basically you just plug in, all this formula is already inside the information we stated up here. Okay, 1.96 squared, okay, times with 0.12. Okay, and this 0.12 is actually the information of P we used to estimate for your pi here. So 0.12 and then here is 1 minus 0.12. Okay, divided by 0.03 squared. So basically, you after you calculated this, you should be getting 450.74. So you round up to a greater value. So you should be getting N equals to 451. Okay. So basically, this is how we want to solve for sample size of mean and also proportion. Okay, so that's all from me for now. I hope that this video will help you out and give you a better understanding on the topic of estimations. Okay, go through one by one the slide, okay, on how to find from the Z and T table, make yourself familiar and go through this sample question that I have explained to you. Okay, thank you so much for your attention and have a good day.